All right, I have a number of interesting things planned in today's lab exercises on repeated measures and longitudinal analysis. We're going to go over all of the things that we did in the lecture, creating and interpreting a notched bar plot, creating spaghetti or, spell this right, spaghetti or line plots for group data, creating a wide format data frame using pivot wider, doing a manual interclass correlation calculation, then a couple of extra things which I think will be interesting. We'll go through how to write a function and use it in this context to perform a simulation, a permutation simulation to get a p-value on that ICC that we calculated manually. So let's start by reading the fecal fat data set and then converting pill type and subject to factors. All right, so I'm going to, let's see, file, import data set, and I'll use readr. Here we are. All right, that's good enough. All right, so there's the import. It looks good. I'm going to take this, my code, put it up in my program. And then, let's see, I'll take a look here, table, pill type. Okay, actually I'm going to call this something else. I'll call this dat instead of fecal fat, and I'll get rid of this. All right, I also would like dplyr so that I'm just going to do all of this in one step. So I had one column, the fecal fat. I just didn't like having a column and a data frame of the same name, which is why I changed the name of the data frame so that we don't get confused between the object name and the column name. So I want to convert pill type and subject factors. So I'll just overwrite them, equals mutate pill, factor, pill type levels equals, and I'll make none the reference. And I could have done it in 2 steps with a relevel, but I'm just gonna okay. I could have done this in 2 steps and done less typing, but that's okay. Now I'm going to do mutate subject equals factor subject. It doesn't matter what the order is there. So let's take a look. I'll do a summary dat. Okay, looks good. So fecal fat is numeric, and our other two are factors, and I've made none the reference level. Okay, first question done. Okay, create a notched bar plot. I'll do this with ggplot2. Just taking a look again, so we're going to want fecal fat as the response variable, and I want to do it with pill type as the predictor. So I'm going to start this with something like gplot. So it'd be like x equals pill type, y equals peak fat, plus, let's just take a look at what that looks like. Oh, sorry, box plot. Okay, so there's a basic box plot. Now, there's a thing called geom jitter. If you want to find this, if you look at the ggplot2 help page, it's ggplot2.tidyverse.org for geom box plot, you'll find the examples with this geom jitter. That was where I found it. And you see what it's doing is actually adding the data points with some jitter so that they're not plotted right along a line, so they don't get plotted on top of each other. And I found I had to add, I had to have add an argument here to get a little bit less width here, just to make them stay within their bounds a little bit more. And I also, for the lecture, did change the size. Size equals 1.5 to make the points bigger. That's maybe a little bit too big. That looked right in the looked right on the PDF. It looks like a bit much here. Yeah, I'll just leave that as 1. Looks pretty good. I also did this to make all of the text bigger. All of this is, I think, sorry, base. It's a little bit overkill here. Maybe I'll keep this at 12-point font. Looks good. And finally, get rid of the legend, since it's not a helpful legend here. I actually think for the purposes of here, I'm just going to get rid of that one. Okay, there's a pretty nice looking box plot. Oh, except I haven't created the notches. I think that is under, yes, notch equals true. All right, so there we are. These little things here, these are the so-called notches. So in the box plot, we've got the belt here is the median. These are the first and third quartiles. We have these whiskers that extend out either to 1.5 times the interquartile range, so it can be 1.5 times longer than this box, or just to the furthest data point, whichever one is closer. So it won't extend out past the furthest data point. These messages here that notch went outside hinges is just showing that, so actually here, this is the interquartile range. It's down here and the notch went outside. So interpret the notches. Maybe I'll just write in here, if the observations are independent, i.e. assumptions of a one-way analysis of variance are met, notches can be used So in cases where these notches do not overlap, it would mean that we wouldn't reject the null hypothesis of these medians being the same in the population. If they don't overlap, then we would. So we saw before from the analysis of variance, there wasn't evidence against the null hypothesis in the ANOVA, and it's the same thing here with these notches. What's wrong with the usual interpretation in this example? Well, these are grouped data. Or I should say grouped hierarchical data, and observations are not independent. Okay, now subtract means from the fecal fat data manually and using residuals of a one-way ANOVA. So manually, let's see, assuming we've got, well, I've already been using dplyr. I don't need to load that. Yes, did that there. So manually, let me just remind myself of what that looks like. So the subject means I'm going to do something like that group by subject, and then I'll do mutate. Let's call this so this is grouped it by subject, and then within those groups I'm going to take the column fec fat minus the mean of fec fat only within that group. So if I do this, I get this new column fec fat minus mean that has these fecal fat measurements minus the mean for that subject. If I wanted to check this, let's see, I don't know, what's mean 44.5, 7.3, 3.4, 12.4. So this first one should be 44.5 minus 16.9, 27.6. So I think it's doing it right. So that's manually, and let's see, residuals of one-way AOV, that would be something like LM So there's the LM, and so this is calculating a mean for each subject, and so the residuals of this linear model are the measurements minus the mean for each subject. So this is all I have to do it this way. So let's see, now let's just take a look. So for the first one, we had, let's see, 27.6 minus 9.6. We see we're getting the same values here. If I wanted, I could do ungroup, and let's see. So that's all right. Oh, I need to do something like mutate feq fat minus mean 2 equals there. There we are. So we can see these two methods are giving us the same thing. So in the first one, I'm really just doing this manually. I'm grouping the data by subject and subtracting the mean for each subject. And in the second one, I'm doing a one-way analysis of variance and taking the residuals. And the residuals of the one-way analysis of variance just have the coefficients for each individual which is the mean, the expected value for each individual subtracted. Okay, make line plots for each subject with and without subject mean centering. Okay, we made these in the class. So let's see, I did this something like ggplot so this group equals subject part. I'm doing this to plot separate lines for each group, and then I also want to give them different line types by subject. Sorry, plus. Oops. So there's a basic line plot. With a legend. I did a bunch of extra things in the lecture to give labels. Maybe I'll do a couple of those things here. Maybe not everything. I'll do this is the raw data. Let's see, I'll add just make nicer looking labels. Okay, good enough. Now I'll make these side by side. Like I did in the lecture. I'm going to make 2 of them. Now the second one, actually I need one of these minus means, so actually maybe I will, I'll store that so that here I have peak fat minus mean. And then I used the grid extra package and laid these out with 2 columns, and I also did this respect equals true forces them to keep a square aspect ratio. So let's, oops, I need to run both of these. There we are. Yeah, I might want to get rid of the legends, at least on one of them. Maybe I'll, for P1, get rid of Okay, let's see what that looks like. Yeah, it's okay, except that it's making them both square. I don't know, what does it look like if I get rid of this? Yeah, I think I liked it better with them square. All right, good enough. I really could get rid of the legend, but it's okay. Point is, we can see the 6 subjects here. You can see the big differences in overall mean and the pattern according to the type of treatment. They are in different order here. Maybe I should have put coded last so that it would have looked like the lecture. I could still do that. All I have to do, the great thing about this, I can go back here, put just going to delete this, tablet, coded. All right, they're in the opposite order. And that's going to change the order there. And there. Now these have the U shape that we saw in the lecture. I'm not going to worry about these right now. It is also possible to rotate these 45 or 90 degrees. Actually, let's fix that. These are annoying. I have some text handy for rotating those X labels. It's this axis.text, theme axis.text.x, element text angle. I'm going to set it to 45 vertical adjustment. 1 puts it at the top, 0 would move them down, and so these are horizontal and vertical justification. I'm just going to test this. Yeah, that looks nice, and I'll do the same up here. Okay. Oops, except this bottom one, this is not raw data, this is subject means subtracted. Oops. Okay. I could call that something shorter. That's okay. All right. Convert to a wide format data set and remove the subject column. All right. So we have, to remind myself what it looks like, I need to, well, I'm going to remove these 2 things. So I'll start with a select, starts with, I'm going to remove these things that start with feq fat minus. Let's see, make sure I'm doing that right. Oops, sorry, I need to select minus those. Okay, so I have these again now. Pivot wider, super handy. It makes turning long format to narrow format very easy. Its transposes pivot longer. Oops, I need tidyr. Okay, let's take a look at the help page for pivot wider. So names from and values from the names or the thing that that I'm going to get the column names from. These are the only column names are the only kind of names there are. Tidyverse doesn't use row names, but it does use column names. So I need names from pill type. So that's going to make columns from the pill type values, and I need values from feed fat. Oh, sorry, these are arguments, of course, not functions. Look at that. Long format to wide format in about as easy a matter as we possibly could have. And we now have this column for subject that is still there. So you'll notice, let's see, so actually maybe I will go ahead and get rid now of minus subject. We don't really need it anymore because there's just one per row. All right. Now we're getting interesting. Write a function to calculate subject or residual variance and ICC of this data set as a vector. So I said let's just do it for this data set because this is a fair bit harder to do in general, to write a general ICC function that for data sets with different column names, with different yes, it wouldn't be that hard, but it would be a bit more work. It's easier for this case. I'm just going to do it for this data set. So, all right, going back to the stuff that we did in the lecture. So all right, I'm going to start with just a regular analysis before worrying about turning it into a function. So we did this fit one way, LM actually I'm going to use the fit two way here, plus pill type, it equals that. All right. Now let's see, the various things that I calculated the mean of those subject means. So one way I could do that would be by using this bit that I did up here. So let's call this wide and then pull wide. Actually, first we're going to need a mean. Let me just check the so we need subject means. Actually, there's an easier way to do this. So I could do this now just by taking the row means, but I think it's a little easier to do group by subject, summarize, mean equals mean peak fat. What does this look like? Okay, that gives us this mean column. Now I need to pull mean. That right? Yes. And then finally, var. There I am, although it has this extra message here, which is a little annoying. I think to get rid of that, I need to look at so override with the groups argument. Okay, let's just drop the groups. We don't need them here. Dot groups equals drop. Okay, same thing, but I don't have that message, and I've calculated here. I've just calculated the mean for each subject and then the variance of them, and I got this 279 like we had in the lecture. So I won't do it this way. So I'll call this subject var, and I'll call that uncorrected. And then the correction that we made was this sum of squares of the residuals divided by 15 over 4. Sorry, this is fit two-way. And yes, that's the same value that we had. And then finally, the residual var was okay. So our output now is going to be, let's see, we want the sub uncorrected minus correction for the first item. Then the second one is going to be the residual var. And then our final one, well, maybe I'll calculate it first here just to make it a little easier, will be I'll make another one here. Okay. The subject variance over the subject variance plus the residual variance. Okay, so now I'm going to return the subject variance, the residual variance, and the ICC. Looks good. I'm going to give it names. I could give nicer names like tau 0, 0. Actually, it would be this squared, so that's a little inconvenient. Let's just call this subject var, residual var, and ICC. Okay, so this is what I'm going to want my function to output. But I haven't written a function yet. All I've done is write a bunch of regular code. So let's write a function now. I'll call this my ICC function. I could use dat here. It doesn't matter if I use the same name or not as a data set that I have. Maybe I'll change the name here just to show you how namespaces can change the name of something in a different scope. So I'll just call this a function of x, say. Now look at this. I'm going to make, this is all I have to do, return output. And I've now created a function. Now inside here, I don't want to use dat. This actually would work because dat exists in my global environment, but it would be a mistake because what I want is a function to be passed through here. So I'm going to call this x. Let's see, is there anywhere else in here I used dat? I don't think so. So there we have it. I'm going to take this, do Command-Shift-A, just to do a little bit of formatting. I've now made an ICC function. Let's see if this works. So ICC fun dat. Look at that. So I can now pass my data dat into this function. Inside the function, my dat becomes named x, and it goes and calculates all of this and returns this output, which is the subject variance, the residual variance, and the ICC. And I have put a couple of things in here specific to this data set, specifically the fecal fat name, the subject name, and the pill type variable here. So this is all kind of specific, but I don't feel like writing a more generic version because other people have already done it, and you'll be using those in the future. So now create a simulated data set where functions are randomized for each treatment. And as you've seen from here now, once you've written some code, it's actually not very hard in R to turn it into a function. So we might turn this into a function later too. But for now, let's see, how do we do this simulated data set? I'll give it some other name like .rand. So I'm going to group by pill type. So that's how I'm going to just do the randomizing for each treatment. So this would keep the treatment effects the same and just randomize the individuals within each treatment. So what it's going to do is get rid of any subject correlations or any difference in mean between the subjects. So after I group by pill type, I'm going to do mutate. I'll rewrite the subject just to remind myself of what this looks like. So I'm going to group by pill type, and then I'll mutate subject equals, and I'm going to use this function sample. And what sample does is it just, by default, if I give it, so if I have something like 1 to 5, and then I do sample 1 to 5, it just changes the order of them into a random order. So every time I do this, I will get a random, the numbers 1 to 5 in a random order without replacement, meaning that I can't have each one of these just gets sampled once. There are arguments to sample that that choose the size that I sample and whether I replace them, and also whether by default, every one of these items has equal probability of being sampled, but I can specify different probabilities as well. Okay, so this is grouping together pill types and then shuffling the order of subjects for each pill type. And then, so I'll just show what happens. That rand looks good, and I think just to make it consistent with before, I'll arrange it by subject. So that just changes the order so that yeah, it's sorted by subject. So these subject 1 now, you'll see it still has 1 none, 1 coded, 1 capsule, 1 tablet. That's why I had to do this group by, because I still wanted each subject to have all 4 treatments. It's just that these have been selected from different groups. This, of course, is no longer valid because these were calculated based on the original subject means, not the current subject means. These would be totally different now. Okay, so compare the ICC for your original and simulated data set. That's pretty easy to do now that we have this ICC fun. There's our original, and for dat rand. So somewhat lower for this. If we did this again, I haven't set the seed, so I'm going to get a different value every time I do this simulation. So far it's been lower every time. If I wanted to get the same value every time, then I need to set this random number seed. And now if I do this, okay, an ICC of 0.4, if I do it again, I'm going to get exactly this same 0.4087945 again. Okay, now something really cool, really challenging. Repeat the simulation 999 times and compare that to your original data set. So this is a permutation test, and it is a way to get a p-value without doing, it's a completely computational way to get a p-value. So what I'm doing is creating a null distribution of these ICCs, where under the null distribution, there is no subject effect. And I know that because I have randomized the subjects for each treatment. So I'm going to, let's see, what does this look like? So I've done it once here, this create a random data set. So I'm going to use that as a starting point, and I'll call this function, say, simulate data. I kind of like this lower camel case. It's called capitalization for functions, but that just tells me that it's a function. It's my own convention. So let's call this function of x again. And then inside this function, I'm going to do x. Okay, and then I'm going to do the rest of this stuff just like before. And then a little hint, I haven't saved this to anything, but I actually don't have to do return on a function. If there's something that would be outputted to the terminal, then it'll also be outputted from the function. So if I had saved this to something like to x or to y or something, then I would have to do x or y at the end or return y. But I can just do this, and the output of this will be returned by the function. Okay, so there we are. If I do now simulate data dat, I get a simulated data set. I probably doesn't matter. These are along for the ride. I'm not gonna use them. Okay, so there's part of it. Simulate dat. What I need to do is run ICC. What was it called? It was called ICC Fun. All right, and then what I want is the third one of those. So there is one simulation. It's going to return the thing I want. Now there's a really easy, I'll put this in another code block. There's a really easy shortcut in R that's just an implicit loop. There are a bunch of ways I could do this loop. The easiest one is with a function called replicate, which just does something a number of different times. It's part of this apply series of functions that apply a function over a list or vector. lapply returns a list. sapply tries to simplify your list into a vector or matrix. bapply is used for programming. It's a little bit safer than sapply because you tell it what the return will be like when you're writing packages and programs. vapply is more commonly used. Replicate is just nice for little simulations like this. So what I'm going to do is I'll call this my sim result replicate. So n equals 999. Maybe I'll do it first just 9 to make sure that it's working, to make it easy to look at the output. And I think that's all I have to do. Sim results. Yes. Okay, so I will change this to 999. I'm going to set the seed again just to get reproducible results. There we go. This actually takes a little bit of time. Now down here, I'm just going to have to do, I'm going to use the base rhist function. It's easier for this because this is a vector, not a data frame. It wouldn't be hard to do this by tidyverse either, but this is really quick. Hist sim results, and I'm going to do xlab or xlimit between -1 and 1, since these are correlations and those would be the limits. There it is. Okay, first thing, I need to get rid of my picture there so you can see. And second thing, I see there's a problem here. I have a bug in my code, and I can tell because these are all positive, and in the simulated results, these correlations should be centered on 0. So I actually am taking a look back up in my code at this ICC fun, which was a function of x, and I realized that I had dat in here again. So when I was passing simulated data to here, it was using the simulated data for this fit two-way, but it was not using it here. It was actually pulling dat from the global environment. So have to watch out for using items from the global environment inside of a function. I think this is okay now. Let's see. And we're getting smaller values now of the ICC. So I'm going to try this again. And I'm going to start taking my next line, AB line, V equals ICC fun dot the original. Okay. There we are. That's more what I expected the ICCs on the simulated data to look like. Centered around 0, more or less normally distributed. And if I put, let's make this color equals red. Here's the ICC on our original data. So it certainly looks like this is not a value that happens very frequently randomly. And if I were to look at that, I would see, let's see, some sim results greater than ICC fun dot none of them. So that tells me that this p-value is less than 1 in 1,000 that it would happen. For me to get a more precise measurement of this, I would have to do more simulations. To speed it up, I think the rate limiting factor in here is definitely this LM, and I could do this without using an LM, although it would be some extra work in here. But for our purposes, this works. All right, so a lot of fancy, I don't know, tricky stuff here, but this use of a function is really useful. This calculation of a permutation test p-value is also really useful, and yeah, using the replicate function, all of this is pretty useful stuff that you can use well beyond this example. All right, thank you. Bye.